Hi. Hi, friends. Let's talk about the problem that you see on the board here. Okay, the problem that you see on the board is 2W plus 5C plus 3W plus 7C. Now, what the heck does that mean? You already saw from a video this morning that I can take things that have similar variables and I can combine them. So let me try to make real world sense out of these wacky letters and numbers here. This is a cup, and inside this cup I'm going to take my kitty cat thermos and pour some water in it. I'm going to pour twice into this cup. 1, 2. 2W is going to be me pouring into the cup twice. You see it? You see it? You see it? Now, what could 5C mean? Everybody's favorite delicious snack, craisins. Craisins, baby. I'm going to take 5C, 5 craisins, and I'm going to add that to my delicious cup of water here. 1 craisin, 2 craisin, 3 craisins, 4, that wasn't 1, 4 craisins, 5 craisins. Okay? You see it? You see it? Now what else? I'm combining all of these things. 3W, so 3 more pours of water. 1, 2, 3. What do I have after that? 7 more craisins. 1, 2, 3, 4, 5, 6, 7. See it? Now, if I were to just combine these things, this is what my combination would look like. So let's see what it tastes like. Oh, that's really bad. Oh, that's really bad. Oh, I shouldn't have done that. I'm gonna throw up. Guys, hold on. I think I'm gonna throw up. Hold on. Oh, why did I do that? Oh, that was such a bad. All right, I think I'm good. That was a terrible idea. That was a really bad idea. I shouldn't have combined those things. I should have just kept things separate. Why did I combine those things? Well, because I'm a fool. But what would happen if it looks like I just took the things that were like each other, like the waters and the craisins, and only combined the things that are alike? Like combining like terms. What would that look like? Well, let me take my water, for instance. I had 2 pours of water. What if I just kept the 2 pours of water and the 3 pours of water and kept them just in the cup? What would I get? 2 waters and 3 waters, or 2 W's and 3 W's make 5 W's. And what if I just kept the craisins separate too? Well, I had 5 craisins. Now I'm adding 7 craisins. And what I have in total is 5 plus 7 is 12. 12 craisins. 12 craisins. Should I combine the 5 waters and the 12 craisins? No. Because that was bad. And I realistically vomited several times. For real. For real. For real. Now let's do another problem like that. Let's change things up. Let's change things up. Let's add a little bit more. I have, let's do 3 apples plus 2 cats. Let me switch markers. This red marker is not really working with me. 3 apples plus 2 cats plus 7 plus 5 apples plus 8 cats. Now, the last thing we want to do, and let's always pretend, tell you what, Anytime I just put a number up there with no attachment, let's pretend it's dollars. So I have 3 apples, 2 cats, $7, 5 apples, and 8 cats. I'm going to throw all of them into a blender and see what happens. Probably a really bad idea, especially the whole blender and cats part. So let's just combine the things that are alike instead of putting them all together. All right. I have 3 apples. Are there anything like my 3 apples? Yep, I have 5 more apples right there. So if I combine the 3 apples and the 5 apples, I get 8 apples. Not 8, 8A, 8 apples. I'm adding the numbers in front of A, and I'm keeping A attached as it is. It's not going to be 3A and 5A make 8AA. It's just like, you wouldn't say, oh, I'm going to take 3 apples and have 5 apples, and now I have 8 apples. You wouldn't do that. It's just you have 3 apples and you have 5 apples, so now you have 8 apples. How about them apples? Oh, I have 2 cats and 8 more cats that I'm going to combine to it. So 2 cats plus my 8 cats are going to be 10 cats. Ooh, it's a cat party. Cuckoo kangaroo. And then I just have $7 laying around, plus 7. Ooh, $7, gangster. That's it. I get 8A plus 10C plus 7. 8 apples, 10 cats, $7. All right. Let's do another one. Let's complicate things a bit. I have 7 dogs and $8 and 5 dogs added to it. But someone's going to take away $10 and someone's going to take away 6 of my dogs. What do I do? All right. I have my 7 dogs. I add 5 more dogs. 7 plus 5 is 12. I have 12 dogs. If someone's like, hey, you, give me 6 of those dogs, I'm going to take away 6 dogs. So I have 7 dogs plus 5 dogs. That's 12 dogs, but I'm losing 6 of them. I now have 6 dogs total. Dog. I also have $8. Cool. Oh, but I owe my friend $10. I'm taking a number and I'm subtracting a bigger number. What does that look like? Well, 8 take away 10 means that I lose all of my money, but I still owe $2. 8 take away 10 means I just do 10 minus 8, but I'm losing money, so I'm still down minus $2. If you take a big number and subtract a larger number, it's going to be negative. So I have $8, I lose my $8, but I still owe 2. This is my final answer. I can't combine the dogs and the dollars. All right. That was combining like terms. In the video, you also learned about distributive property. So let's just say, let's go back to the craisins example. There's 6 people in my family. I have 2 guys, 2 boys, and 4 girls, including me and my wife. Okay? Someone comes up with craisins and they're like, here, you, give everybody in your family 3 craisins. How much will go to each group here? How many will the boys have? How many will the girls have? Well, if I give 3 craisins to each boy, that means I give 3 craisins to my son. I get 3 craisins. We add them all up. 3 and 3 makes 6. Or I could just do 3 times 2 is 6. And that's what the boys get. So you multiply the numbers and you bring down the variable with it. Similarly, there's 4 girls in my family. If I were to say, here's 3, here's 3, here's 3, here's 3, that's 3 times 4, which is 12. 3 times 4 is 12, and then the G comes along for the ride. That's it. You can't combine the G's, you can't combine the B's. They're all separate. So 3 times 2 is 6. B comes along for the ride. Everything was positive, so bring down the plus sign, and 3 times positive 4 is positive 12. Bring the G along for the ride. Let's do another one. Let's make the numbers a little less pleasant. What if I did 3? So we'll do 3 again. I don't know why I keep using 3. And we have 5 apples, and we're going to lose 3 cats, and just plus the number 6. Now I have 3 objects inside the parentheses. So what happens if I'm multiplying a number to 3 objects inside the parentheses? Well, take that number on the outside of the parentheses, multiply it to every object inside the parentheses, and bring the variable along for the ride. 3 times positive 5 is positive 15, and then A comes along for the ride. 3 times negative 3 is negative 9, and C comes for the ride. Now, if you're like, no, that's not a negative sign, that's a minus sign. Negatives and minuses are the same exact thing. If you ever heard that they're not, they're wrong. They're the same exact thing. 3 times negative 3 is negative 9. C comes along for the ride. 3 times positive 6 is positive 18, so bring down the plus sign. No variable to attach to it. We're done. Okay, so let's do one more. Let's add a few more negatives to this. Few more negatives. Let's do negative 3 times 8 minus 4x. Again, we have a negative number being multiplied to a parentheses. Take that negative 3, and multiply it to every object inside the parentheses. Negative 3 times positive 8. Negative times a positive is negative. 3 times 8 is 24. This is where it gets weird. Negative 3 times negative 4x. Negative times a negative is a positive. Negative 3 times negative 4 is positive 12, and then x comes along for the ride. So I have negative 24. I have positive 12x. I can't combine them. That's it. We're done. Now, what if I wanted to do a combine like terms and distributive property problem all in the same problem? This is what it might look like. Are you ready? Let's do 2 times x minus 4 plus 3x. What I have is I have distributive property happening. So remember from PEMDAS, distributive property means you take that number and multiply it to everything. According to PEMDAS, you multiply before I even think about this positive adding thing. So I'm going to multiply 2 to x. Now again, distributive property, as you multiply the number on the outside to all the numbers on the inside. Well, where's my number? I don't see it. That's because it's invisible. And it's actually invisible 1. So 2 times 1x is going to be just 2 x's. 2 x's sounds like my dating history. 2 times x is 2x. 2 times negative 4 is negative 8. Oh, and let's not forget that this positive 3 I didn't even mess with yet. I haven't even touched it yet. But I'm not done. Because I have 2 x's over here, and I have 3 x's over here. Sounds like an awkward party, right, guys? Because the x's are in the same room. All right, so if I have 2 x's over here, and I have 3 x's over here, and I combine them, I have 5 x's. What happens to my minus 8? Does that combine with anything? No. So I have minus 8. 5x minus 8 is my answer. So that's it. I'm done. Combining like terms, distributive property. Okay?